So the next definition is door edge seam, and door edge seam is actually a bit of fun unless you aren't enjoying working on a door edge seam that doesn't agree with what you're working on. So the way that a door is manufactured, the type of door, meaning the series of door from the manufacturer, has everything to do with the type of door edge, meaning what does it look like? How is the steel brought together from this face of the door to this face of the door? What's happening on the edge? And it's important to know what's happening on the edge, especially if you are in a shop setting. So we'll look at the Seco catalog, but an easier example would be what Kawani used to make back, a couple of 3, 4, 5 decades ago. They've long been out of business. And Amweld's a good example, another company who's out of business as well, because they were doing something neat at the time, although I think it was they had fits and starts with it. So first of all, we're just talking about door edge seam, but it's important to say door edges can be square or beveled. They can be rabbeted. They can be radiused. The point of the door edge seam is how that steel is brought together, whether it's beveled or square edge. I can think of instances where it applies that you only see this type of door edge when it's beveled, etc., etc., but I don't know that there would be a strong argument that it's true, actually. So you have lock seam, where and the steel from this side to this side is called a pan. You have a piece of steel, let's say you're going to make a 3-foot door. Well, that piece of steel, that sheet piece of steel, it's wider than 36 inch because it's going to be the net size of the door plus the loss for the bend and then whatever the return is. And that's probably some digit that is in the second or third decimal place when they're shearing the steel and then putting it into a press brake with a with a backstop. And generally there are two people who do that. When you take a 3-foot piece of steel, I'll hold it on this end and you hold it on that far end, and we'll take that together and we'll put it into the press brake. I'm not a manufacturing machinery expert, but I have a little bit of knowledge of how it works. Probably CNC back aging, numerically controlled back aging. You're going to run a program and it's going to automatically move the backstop to a certain distance. You and I will take that steel and we'll push it in, and we'll push it all the way against the backstop. And one of us will hit the foot pedal kind of situation, and the brake will come down, and then you and I will both see that steel is going to, flip up like this, so we both have to be ready to lift our arms to support the steel. And then we'll flip it around and do the same thing on the other side sort of situation. I've seen that done. So you can have a lock edge seam, which is extremely common. And when we switch to the screen view, we'll take a look at it. There's a pan and skin style that I'm not exactly familiar with. Amweld may have been doing that and then continuously welding on their laser edge doors. There are the center seam doors as well, which are awful if you are in a shop setting. You don't want to work on those at all. And that makes me think that I should say, depending on not who the manufacturer is, but what door you're building, that may very much inform the edge seam construction that you'll see. If you're doing steel stiffened, you're probably going to have a different construction. Steel stiffened, lead line, things of that nature, you'll probably have a different edge seam construction than you would otherwise. So lock seam, pan and skin, center seam, and center seam can be without the returns, with or without the returns. I will tell you why the with the returns can be dreadful if you're prepping it, and you want to know that ahead of time. So let's switch to the screen view and let's take a closer look at the supporting information. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, here is our definition, door edge seam, the connection of face sheets at the vertical edge. Lock seam, pan and skin, and center seam, with and without the returns. Now the problem, let's just start in order. Lock seam, that's going to be a Seco Regent, or the old Kawani E door. And generally what there is a tab and slot construction inside of here where the sheets are just mechanically connected. You can also take this sort of design and you can weld that area here and making it a seamless door. So let's don't want to get ahead of myself and forget points that I'd like to point out to you. Let's get into the Seco catalog and look at the Regent door. See if they show anything in the catalog. Yeah, not really well. Actually, this could just be pan and skin. This is going to be pan and skin with tabs. So the Seco Regent is going to be this pan and skin, except that you have tabs. So what's happening here is when you lay this piece of steel on top of this pan, you then have to basically force this piece of steel up that way to interlock all these tabs and slots together. And that's typical. That's very common. It's also common as to why you'll see Regent doors fail, because they're probably the most common door there is, but also there's no welding done at all, and they're generally honeycomb. So yeah, we go back to an Imperial or Versador. The difference there is beveled edge versus square edge. Now you can take these doors and the Regent, Legion, not Legion, it's the Regent Omega, and you can weld those. So it will give you welding if you were to order it that way. The base, though, is mechanically interlocked, hemmed vertical edge seam for strength and rigidity. Okay. Now, when you get into a door like a steel stiffened door, you're going to have a different construction. They're not tabbing and slotting this all together. There's probably two pans without a center seam. It's probably just this construction is what's happening. And then that edge gets welded. Now, in the old Kiwani D door, that would have looked just like this, in fact, except they would have welded outside of here. Not all the way down, but there'd be a lot of welding done, grinding, bondo, sanding is what would be done on that. So the door construction infers or informs us about what the edge seam is going to be like. So the next document I would like to take a look at would be the SDI document. Yeah, okay, Technical Data Series. So Standards Technical Data Series, SDI 108-23. The -23 is the year form. This is important. This document I refer to of all of them most often. So you'll see in specifications it'll say level something, 1, 2, 3, or 4, and then model. The model has everything to do with what's the edge construction. Is it full flush? That means no welding. Or is it seamless? Which doesn't necessarily mean fully welded, but it means there's no edge seam visible. Imagine if this line was continuous, which it would be if you were to weld, grind, bondo, sand here or here or here or here. You can fill all of those. And some factories will have bondo only or welding in bondo to fill that because architects don't want to see that line. Possibly the reason they don't want to see that line is obviously for aesthetics, but also they may be well informed in the sense that it makes for a stronger door when these two pans are actually when they are beyond mechanically attached. When they're actually welded together, they become one cohesive piece of material. So this table in SDI 108 I refer to often because I don't have these memorized. Level 1 or 2 or 3. This I kind of have memorized. 20, 18, 16, 14 gauge. Those are the available models. And I know that the heaviest one is 4 because it has a 4 here. And then I work upwards from there. But this, level 1, level 2, you can kind of remember that. Level 1 is full flush, meaning no welding or bondo. Level 2, or Model 2, forgive me, Model 2 is always going to be seamless. The next document I'd like to take a look at would be a technical manual. Let's see if this reveals anything to us about door construction. Regent. All 6 panel designs are center edge seam construction. That makes sense because the panel design, the core has to be molded in such a way that the panels can sit on and sit flush. Welded, so that's a reference to how the door type, the construction will infer what's happening on the edge. They can't do this tab and slot because the pans are embossed with the panel design. The core has to be made to prep, so they can't do tab and slot with that. This honeycomb, that appears to be a tab and slot construction because it's honeycomb. That's interesting. I wonder how in the factory they change the thickness of the honeycomb to account for the embossing. I'd like to see how that's done. I don't know, other than they're probably modifying it somehow. And then, in part, compromising the integrity of honeycomb. 14 gauge Imperial Maxim doors with a polyurethane. Yeah, not showing us a lot here, although we do get the picture or the idea of what's being done. And then, well, yeah, a Versa door, obviously mechanically interlocked hem seams. That shows you what it is there. So that's all really important to take a look at. Now, probably what's happening is there are two pieces of steel that are exactly like this, and they just turn them end for end. So the other side would look symmetrically the same as this. The small side of a bevel door will have this edge, and this is really typical and common where there's just steel welded back there. Now this type can be dreadful, and imagine that you have to add a deadbolt prep to this, and you want to use standard mounting tabs. Well, it ain't gonna work, and you'll find that out the first time you try to do it, because this tab is not going to. You take this edge and you do a 2 1/4 by 1 1/8 prep, you still have these returns here. Well, I remember the first time I encountered that, I said, well, that's dreadful. And then we obviously just we made a slit down here, and that worked. However, Major has them. Well, Major and others. Major doesn't call it split tail, but DKS does. So you can order split tail reinforcing tabs, and it's because DKS doors are made with that sort of construction. These are imported from China. People that came out of Amweld, I think one of these letters is the person from Amweld, I don't recall. D, I think, probably stands for David from Cal Royal. Product catalog, let's take a look. I don't know if they give us really any, oh, they do. Okay, they don't inform us really well what the edge, well, sure they do. They show it right here. It's a weird drawing, but they show us. So, pan and skin, I would call this if we're using SDI terminology. There you go. There's your edge seam with the requirement of the split tail. So these are just two pans that they're bending and plopping on top of each other once they've got the honeycomb tossed in with probably a small amount of adhesive. And as an aside, the reason that honeycomb is not desirable is they found that in order to get the honeycomb to adhere to the inside face of the door, they have to actually remove the primer, and they also have to put the honeycomb core through pinch rollers to flatten it out, to give it some surface area. So you're not only exposing raw steel, that's why they rust, from the inside out, and two, you're compromising the inherent integrity, the natural integrity of honeycomb when you put it through a pinch roller. So that's very interesting that DKS has this. One more technical manual that I've kind of been going to is this company called DCI, and not the out-of-business trim and auxiliary company in Michigan. Hollow Metal On Demand, I've been enjoying their technical manual of late, and I can't say that I know very much about it. Frames are in the beginning, which is how I would like them to be. And then we get to the doors. Let's see if they infer anything specific about their door construction. Yeah, I don't see that they do. There we go, door details. Standard door edge seam. Let's take a look at that. Yeah, nice. They come through again. Pan and skin, I would call this. Fill it or don't. They may be filling it automatically. Okay, sure. So they're doing a continuous weld, and they're doing spot welding with Bondo between, most likely, or not. The tab slot, the edge over, they call it lock seam. I forgot that already. Lock seam they can do. That is going to be the center seam, this model right here. That's great. I don't really know how they're welding this. They can either leave that visible or fill that. And then top channel, that would all be spot welded. I mean, this tells me that it's spot welded. I just don't know how they're spot welding this interior channel. And probably available both square and beveled edge. So that's a neat way to look at all of this as well. This is a fun technical manual, and feel free to use it. Okay, so the bottom line is if you're doing this, be sure you have the right mounting tabs. I had mentioned the name Major, and I do want to show you the LMB-01 would have split tail. That would be really typical. So if you've got that edge center seam here, you'll want that sort of reinforcing bracket, or you'll be slitting your own. The next definition is door face, the exposed surface of a door, not including the vertical edges. Yeah, let's talk about that next. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.